Dear students, now today we are going to discuss about the curvature. All the mathematics and engineering students, they already know about the curvature and radius of curvature. So once again, we are going to revisit about the curvature. So at each point of the curve, we have defined an orthogonal triads, that is T, N, and B. Already we have discussed tangent, normal, and binormal. Also, it is observed that at every point, this moving triad determines three fundamental planes. In my previous PPT, we have discussed normal plane, osculating plane, and rectifying plane, which are mutually perpendicular. All these three planes, just you look the previous PPT, you will find all these three planes are mutually perpendicular to each other. We may study their variation from point to point with respect to the actual length as parameter. This leads to the notion of curvature and torsion of the space curve. So first of all, we will discuss the curvature. You know, if this curvature, just you look, if this say a small radius, if radius is small, high curvature. Large radius, low curvature. Okay, so radius of curvature, compression. So in this figure, you may compare about their compression, radius of curvature, compression is small radius, high curvature, large radius, low curvature. Okay, if you look here in the curve, so it is well known if you concentrate here in in this figure, then there is no continuity. But here, this point, this is the point of contact, and they are touching these 2 points. This is touching through this point. Okay, but here this is called the tangent. Tangent through these 2 points. Tangent at this point. But here, this is the curvature. Just look the curve. This is the curvature. This is curvature. Okay, and whenever we talk about this acceleration, so acceleration is like this. How you know the acceleration? Acceleration is we define the velocity ds by dt, and dv by dt is your dv by dt is acceleration. So if you drop s and t and then ds by dt is v and t and then acceleration a and t, then you will find this is G3 graph. So this is the basic of the curvature. Now, if you go through more detail about the motion in several dimensions, has two aspects. One is its speed of motion, the other the shape of the curve. Okay, it follows the former is measured by the speed of motion, as I said, because I have shown you the acceleration, last graph of acceleration. Then that is ds by dt. The latter is measured at each point by the curvature of the curve. Rest, this is the magnitude of the rate of change of a unit vector, rate of change of a unit vector in the direction of motion with distance along the curve. Its dimension is that of an inverse length and is reciprocal of 1 by k is called the radius of curvature. The curvature is proportional to the component of the acceleration. It's very important. Because of that, I have shown there the acceleration graph also. The curvature is proportional to the component of the acceleration, normal to the velocity with a proportionality constant that can only depend on speed. So this is already discussed in undergraduate level detail how we are saying this. All the proof, all the related formula is already undergraduate levels for the mathematics student. Now it means the arc rate at which the tangent changes direction as the point P moves along the curve is called the curvature. Now you have to remember this. vector of the curve and it is denoted by k. So curvature, we will denote this curvature by k. Therefore, by definition, k is equal to nothing but dt by ds. And k is called the curvature vector and its magnitude is mod of k is called the curvature at p, and this is denoted by small k. But rho is known as radius of curvature and this is defined by 1 by small k is called the radius of curvature, where we take the absolute value of rho. So this is about the curvature, which is very important part of differential geometry. Thank you.